بسم الله الرحمن الرحيم رب زدني علما.
Now, again, in today's scenarios, we'll be using RIP version 2. Means we don't even use RIP version 2, of course, but just to understand the difference, whenever we talk about RIP, anyone using RIP in today's scenario, you will see they will be running RIP version 2. The main difference is the RIP version 2 is classless, which will carry the subnet mask information, supports your subnets, the VLSM designs, which is one of the difference. And the other things, it basically the updates are sent via multicast. So there is a special class D address reserved called 224.0.0.9. So whenever any update is sent on 224.0.0.9, it is specially for RIP updates. So if the opposite router is running RIP, then it will listen to that updates. If the opposite router is not running RIP, it will not listen to that update. That is one additional thing. And of course, the other OSPF also uses multicast, EHRP also uses multicast, but there's a different class D address reserved for that. So basically, the multicast address is just like your FM stations where you tune to that frequency, you get the signal. Similar way, the updates will be sent on this address, and if the opposite router is running the same protocol, it will be able to listen to that updates. But if the opposite router is not running RIP, it will not listen to that update. If the opposite router is running RIP, it will listen to the update. But whereas the broadcast is irrespective of you running or not, you will listen to that update. That's the difference. So it is more a customized way to send the update to only the routers which are running RIP, not to everyone. So which means even though update is sent on, if this interface is enabled, it will send the update, but the opposite device is not going to listen to those updates or not going to respond to that. Another difference, like mostly all the protocols, they have authentication. Authentication is something we don't cover in here in the CCNA, but when you go to advanced routing, authentication is nothing but we can configure the password. Like there is a possibility that some attacker someone in my company sitting here can add one router and he will advertise this as 192.168.3 network, and he will run the RIP protocol and he will advertise itself as an RIP. So from the router 1 to reach the actual 3 dot network is here, and to reach this 3 dot network, let's say there are 2 hops. Here, as per this example, it is 2 hops, but whereas from the router 1, it is just 1 hop. He will tell that it is only 1 hop. So what happens? The router 1 may end up sending the update to this side, which is actually the wrong information. So which means in simple, anyone can simply connect a simple router and advertise his own network as a fake network or additional network and may propagate some wrong routing information. So to prevent that, we can enable some passwords. So we can configure some passwords saying that the routers should only exchange the routing updates if they match the password. So if there is a mismatch of the password, the authentication should fail and they should not form the neighbors or they should not exchange the updates. So that's something supported in almost in all the protocols today. So every protocol supports that, but the version 1 do not support because, as I said, it was one of the earliest protocol where they did not think about all these factors at the initial time. Okay, so slowly as the development happened, the different reasons like introduction of the subnets and introduction of the multicast and then authentication, these all things added. Okay, so apart from this, all the remaining are still the same. So RIP still uses periodic updates here as well. For every 30 seconds, that is the same thing. If you compare, the metric is hop counts, that is again the same thing. Maximum hop counts is 15 hops, that is again the same thing. So apart from this, rest of all the features, whatever we covered, it's going to still the same thing. There are few changes. Administrative distance is still 30, maximum hop counts, other points remains the same. So only few things has been updated. But again, as I said, in today's scenarios, you don't see the RIP protocol being used. But again, as I said, I'll be covering this protocol just to understand the behavior of the dynamic routing protocols. And of course, every protocol works differently. Every protocol have their own way of doing the things.